Okay, today we're talking about 4.8. We're talking about isosceles and equilateral triangles, which we've already discussed briefly before. Isosceles triangles, remember, has two sides that are the same. So we have those tick marks. And because those two sides are the same, we also came up with the fact that those two angles are going to be the same as well. And you don't necessarily have to draw your triangle this way. If you really want to draw it this way, you can. And these would be the two congruent sides, and these would be the two congruent angles that are across from those two congruent sides. So there's some terminology that I want us to be familiar with. The legs of an isosceles triangle are those congruent sides. So I would write down that the legs of an isosceles triangle are the congruent sides of the triangle. The vertex angle is the angle that's in between the two legs. So this one is the vertex. Or in this picture right here, angle 3 would be the vertex angle. The base is the side that's not congruent, the non-congruent side. And the base angle are those angles that actually touch the base. So the angles that touch the base and they're congruent. So in this example, angle 1 and angle 2 would be base angles, and they would be congruent to each other. Now, we've already kind of figured this out in class, but in geometry they give it a special name. The isosceles triangle theorem says that if we have two sides that are congruent, then those opposite angles are going to be congruent. So I'm a picture person, so I would say if I know this, then I know this. And again, we kind of already talked about that in class. The converse, remember converse just means we flip those two statements around. So notice in this theorem, I told you that those two angles are congruent, and then you can conclude that those two opposite sides are going to be congruent. So if I was going to write that down on my cheat sheet, it would look like this. If I have this, then I know this. So again, I would write this on your cheat sheet. Okay, so how we're going to use that today? Isosceles, just talking about isosceles triangle. For number 1, it says find measure of angle F. So we want to search for this angle. Well, we know that all angles add up to be 180 degrees in triangles. And we also know since these angles are congruent, these sides are congruent, then these angles have to be congruent. So if you wanted to, there's a couple different ways you can do this. You can call this X. And since that angle is X, we can also call this angle X. And then we can add up those angles and set it equal to 180 degrees, since all the angles add up to be 180 degrees. And then so we subtract 22. And now we have 2x equals 158. And then we divide by 2, and we get x equals 79 degrees. So if we check it, if we plug it in, 79 plus 79 plus 22 should equal 180 degrees. So that's one way to think about it. You can do number 2, very similar to number 1. Number 3, obviously I'm going to make it harder. Number 3 is a little bit harder because, sorry, I didn't finish this problem. Measure of angle F equals 79 degrees. Number 3, I made it harder because I threw in some x's, but we're still going to do the same process. Since these two sides are congruent, that means these opposite angles are going to be congruent. So these opposite angles are equal to each other. So I know angle G equals angle J. And then I can use substitution. X plus 44 equals 3x, and then solve from there. If I subtract an x from both sides, subtract x, then I have 44 equals 2x, and I have x equals 22. But remember to go back to the problem. I want to define measure of angle G. So then I'm going to have to plug in measure of angle G equals x plus 44. So 22 plus 44. My final answer is 66 degrees. You could check your work by plugging into this next one. If you took 22 and plugged it in here, again, we said that they're the same thing. 3 times 22 is also going to be 66. So you're going to be responsible for finishing number 2 and number 4. Okay, last thing we're going to talk about is the equilateral triangle. Equilateral triangle, all the sides are congruent. So since all the sides are congruent, that means all the angles are going to be congruent. And we also said, this is another side note, that all the angles equal 60 degrees, right? Because 60 plus 60 plus 60 has to equal 180 degrees. So that's the equilateral triangle theorem, you could call it. The equiangular triangle is kind of like the converse. If I tell you all the angles are equal, and thus all the angles are congruent and 60 degrees, then all the sides are going to be congruent. So if I wanted to draw it as pictures, if I have this, then I know all the angles are congruent. And conversely, so if you flip it, if you have all the angles are the same, then that means all the sides are going to be the same. So in this, with equilateral triangles, we're going to be solving for angles and for sides. So you're going to have to pay attention to what they're asking you for. For number 5, for example, there's a degree sign and it's pointing to an angle. So I'm solving for degrees. I also know that this is an equilateral triangle. So since it's an equilateral triangle, all the angles have to equal 60 degrees. So I'm going to say that 2x plus 32 has to equal 60 degrees. And I'm going to solve for x from there. So subtract 32, 2x equals 28, and then divide by 2, and x equals 14. So that's my final answer. If you wanted to check it, plug it in, and it should equal 60 degrees. So that's one problem of how you can do angle measures for equilateral triangles. For number 7, this is an equiangular triangle. It's equiangular because all the angles are the same. Since it's equiangular, that means all the sides are the same, and thus it's also an equilateral triangle. So this one says find JL. Now we're talking about a side length. Remember, side lengths have nothing. Side lengths are never equal to degrees. Do never set a side length equal to 180 degrees or 60 degrees or any degrees. So since we know that this is equiangular, all the sides are the same. So we can just say that this side equals this side. So JL equals KL. And then you can substitute and solve from there. So subtract the 2t. Now I have 2t, add an 8, and I have 9. And so I have t equals 4.5. And I wanted to find JL. So if I took 4.5 and plugged it in, JL would equal 2 times 4.5 plus 1. So that would be 9 plus 1. So my final answer is 10. And if I wanted to check my work, all I'd have to do is plug it in here, and I should get the same thing. Okay, so those are the different types of problems. You're responsible for doing 6 and 7, as well as the reflection, and I'll tell you what the math humor is after we do tomorrow. The last one is a real-world problem. It says, if the distance from Earth to a star in September is 4.2 times 10 to the 13th kilometers, what's the distance from the Earth to the star in March? Explain. So let's say this is our sun right here. And here's our lovely planet Earth. And the Earth rotates around the sun. Right? And one full rotation is a whole year. So let's say it's September. And here's where Earth is. And here's the star that we're talking about. And the distance from Earth to that star is 4.2 times 10 to the 13th kilometers. Now, if we rotated, and now we're talking about March, that's half of the year. So we've rotated around the sun halfway. So that means, since it's been half of the year, that means that these are congruent. And so the distance to that star in March is also going to be 4.2 times 10 to the 13th kilometers. So that's your final answer. Okay, so you're responsible for finishing the rest of the notes. Fun fact of the video. Did you know that it would take you about 1,000 years to watch every video currently on YouTube, including this one? Hooray! Videos left.